Now, all that is wonderful and amazing, but it's also where we bump into our first problem.
The reason that as astronomers we believe that life is so abundant in the universe is because of the vastness. It's kind of a numbers game. But that vastness is the same reason that we don't believe that that life will ever get here to us on Earth.
They can't get here. Remember, we're trying to stick to reality, not the Star Trek universe. That means asking if it's possible to travel faster than light, because civilizations are going to be very, very far away.
So as scientists, we are bound by what we can test and observe. And what we observe is that nothing can travel at the speed of light except for light itself. It would take an infinite amount of energy to accelerate anything with any mass at all to the speed of light.
So faster than light travel is not possible because of the part of physics called relativity. And in relativity, the faster you move, the heavier you get and the shorter you get. And so as you approach the speed of light, you become infinitely massive and infinitely flat.
I hear terms like relativity, like Einstein, and laws of physics. Are these just ideas that human scientists made up?
So you may naively think that the laws of physics are something that we came up with as humans, but these are not legislative laws. These are really observations that we have verified time and time and time again to the point that we really consider them unbreakable laws.
Is it possible that some aliens might come to us from a different part of the universe that might have different laws of physics?
No, it is not possible. The laws of physics are the same everywhere.
How do you know?
So we actually can use the James Webb Space Telescope to look back in time, because the farther away something is, the longer light has been traveling to us. And so when we look back in time, we can see something called the cosmic microwave background. Now, this is the leftover light from the Big Bang, and this light dims like a dimmer switch. And we've been able to use the laws of physics to say, okay, it should have been this bright at this point of time, and now it's this bright at this point of time. And those line up perfectly. So we know that it's different parts of the universe that we can see billions and billions of light years away. Those laws of physics are exactly the same as the laws of physics here on Earth.
Okay, so if the laws are the same everywhere now, have they always been the same?
By looking at gravitational lensing effects, we've been able to determine that gravity behaves the same today as it did 5 billion years ago and 5 billion light years away.
The entire universe obeys the laws of physics as we know it. We can look way back in the universe and compare our observations to some of the models that we create based on the laws of physics we know now. And we can see that these two things match. So these laws of physics have been the same laws of physics ever since the beginning, as far as we can look back.
So that's disappointing. These barriers to faster than light travel are the same here as they are for a civilization on the other side of the universe. And those problems we face today were the same for civilizations a billion years ago. But the problems don't even end there.